Perfect. All right, I'm Morgan Cundiff. I'm a data scientist at a company called ShopRunner. My pronouns are she, hers. And today I'm going to talk about developing data science to add business value. So it's not going to be a super technical talk, but I will step through a computer vision project just to go into examples about what I learned about developing specifically to add business value. So, can go to the next slide. First of all, why do we want to do this? A lot of data science projects, especially in research, set up to develop new techniques and new models and really innovate on the systems that we use. So why would we want to restructure an entire project specifically around adding business value? So first off, I'm really operating under the assumption that we all enjoy being part of data science projects and enjoy the challenge that goes into building them and creating them, but also that we want to make an impact, right? And we want to use those insights or those predictions that we make and really make an impact on what we're doing and the business that we're working with. And that brings us to this statistic, which is only 13% of data science projects actually make it into production. And this is a really low number, right? So if we are spending all our time building these new challenges, building these new models, no matter how amazing they are, and no matter how great they work or how effective they are or how innovative it is, if we're never making it into production, they're really not having the impact that we wanted them to on the business or on the cause that we're focusing on, right? So this is also true from the company side. So this is a quote from Deborah Luff, the CTO of Data Science and AI at IBM, who said, if your competitors are applying AI and they're finding insight that allows them to accelerate, they're going to peel away really, really quickly. So this demonstrates how crucial it is for data science projects to move forward, right? A lot of companies spend a huge amount of resources, whether that's time or money, on data science projects and data science people. So if those are never adding business value, that can seem like a lot of wasted resources. It also means that if they're never making an impact, they're never seeing that benefit, right? And so their competitors are going to move away. They're not going to be able to innovate as fast. It can really ding the company overall. Plus, a lot of us in this room, I'm guessing, are data scientists or support data science projects. So if we can never use those projects to add business value, we're going to have a hard time justifying our jobs in the future. So hopefully that's a little bit of a motivator. So what are the obstacles we face to doing this? What's blocking us from doing this, and why is it so hard? First off, a lot of data science is seen a little bit like magic, right? There's a real lack of understanding of exactly how our projects work, how is software engineering or other types of tech different from data science, what really goes into a data science project, and how that works. So I think we face a lot of problems where we're trying to justify why we need certain types of data, why we need that to be clean, and not everyone quite understands how that works, what they can request of us, or why that needs to happen. So this means, people don't even understand how to use our projects once it's done. So you spent all this time making this amazing model or building out this feature, and then someone doesn't know how to use it, and you're stuck justifying this project that they don't understand and haven't been a part of. Also, these same people face tons of competing priorities, right? So whether they're engineers or they're product people, they likely have these really busy roadmaps and a lot of their own work that they want to focus on and build towards. And so they don't always have this time to budget to focus on your projects, whether that's getting them into production or even just using them once they're already in production. So especially since data science can have really long development cycles, right? So a lot of data science right now is very experimental. We might have to start off with a lot of research, a lot of development. Our first try might not always work. So when we have these super long development cycles, it's really difficult to keep people engaged. So I think a lot of these talks focus on how to get data science people excited, or how to get other people excited in data science projects from the very beginning. And while that's super important and really crucial, it is not the full story, right? So if you get someone excited and then the data scientists go off on their own and develop for 4 months, 6 months, however long it is, when you come back, you're not necessarily on that person's roadmap anymore. You're no longer a priority, and they might have moved on. So it's really important that throughout this entire cycle, we be keeping people updated, keeping them informed about the project, so they truly know what's going on. All right, so who am I and why am I talking about this? I have a kind of interesting background. I studied bioinformatics in undergrad and actually worked as a biologist studying Alzheimer's and diabetes. So these images here are of corneal nerves, so different layers in the eye. And as anyone who's done research knows, I have looked at these way too long. So if you've ever been in a lab, I'm sure you spent way too much time looking at your data. And so while I was working there, we didn't have a lot of technical support, and we had to get technical support from outside. So I had a lot of experience having no technical background, being a biologist, and working with the other side and trying to communicate. So a lot of times we would get projects that we had no input in, that we didn't fully understand, that we were expected to use, and then trying to integrate that and trying to budget our time of how we're going to use this is a huge deal. So that risk factor, right, of getting a project that you don't necessarily know you need, you don't know if it's going to work for you, you don't know what went into it, and now you have to put aside your own work in order to figure that out and how you're going to use it. And so I learned a lot through that experience of exactly what needs to go into that communication, but also the other way around of how hard it can be when you are the subject matter expert trying to communicate what you need to technologists when you don't understand what they can build and how they can build it. And how that can be really difficult if you've never seen the project, you don't understand how it works, how do you communicate what features you need or even how those features should be structured. So I then moved on and was a software engineer at a phone server company called Digium. This is actually one of the phones that I worked on while there. I know not a lot of people see desk phones anymore, so it's a little outdated. Most of the work I did do there was on mobile development, so a little different, but this was also a pretty fun project too, since I don't think many people get to use desk phones anymore. I did learn a lot there. Sorry, I keep taking this microphone. I did learn a lot there about the differences between software engineering and data science. So I think in software engineering, sometimes, it's a lot easier to do things like demonstrate partway through a project. And the things that come easier about working with other teams when they can see it, when they know what's going on, when they've used a phone app before and they know exactly what that looks like. And so I think while those processes tend to be very different, I have learned a lot about what is important about that and working with other teams and how to bring that into data science, even if we don't get some of the things for free. All right, I now work for a company called ShopRunner that bills itself as the Amazon for the other half of the internet. So we partner with a bunch of brands, including Saks Fifth Avenue, Bloomingdale's, Tory Burch, Neiman Marcus, and about 130 other retailers to bring all of our members free 2-day shipping, free returns, express checkout, and a bunch of other member benefits on all of our retail partner sites. So while there, I work on a project called Phoenix. And it's called that for a couple of reasons before I get into exactly what it is. So our data science team decided, before I started, that all of our projects were going to be named after Harry Potter themes. So that's why you see the Harry Potter picture before. Also because it's bright and colorful, and Phoenix is about color. So you'll see that a little more in the future. But also because it was a pretty experimental project, and I knew we were going to keep iterating on it, and it was going to keep coming back again and again. So you'll see that as a theme throughout the rest of the talk is really about how we brought it back and how we iterated on it, and how each time we got feedback, good or bad, we just iterated, moved forward, and it kept coming back over and over. All right, so now I've explained the name, which, as we all know, is half the battle with starting a new project in tech, naming things. And so what actually is Phoenix? So the idea of Phoenix is color identification. So here we have an example of a product image from a retail partner. And maybe we want to get an RGB value out of that. This is the corresponding color swatch. And then maybe we want a specific name for that color. So why do we want to do this in-house? So the data we get from retailers on color products is often pretty messy. A lot of times they don't send us color at all. Sometimes they do send us color, but it's wrong. And then even when those colors are right, each of our retail partners can have a different set of color names, right? So if we want to do something like take a product from one brand and show it on a particular retail site, maybe that color name that we get for that brand doesn't match a color the retailer has. So we want to be able to in-house take in those products, give them all names or at least RGB values that everyone can use, and then pass them forward. Okay. So this is an example, again, of when we have multiple colors in an image. So this can be like, or in a product. So it can be slightly more difficult, but a lot of times when we get those colors from retailers, we just are getting a single color, but we also want to be able to filter for multiple colors as well, right? So someone looking for this dress, the primary color might be this pale blue, but they might have also searched for something that was yellow or this pale pink, and we want to see all of those colors that are in the product and not just one that's given to us by a retailer or one that we detect. All right, so how should we start developing, right? So I think this is a big point of the talk, and we get into it. So we'll start with a few examples, but start off with something I think most people already do, right? So at the beginning of a project, you get a bunch of people into a room. You want to talk about what is this project going to do? How are we going to build it? And so at some places, this is like mostly data scientists and engineers, but I think a lot of places do a pretty good job now of also having product people in the room, right? Also having people who are going to use the product, whoever your stakeholders are. And I think that's crucially important to have this conversation with everyone so that you're fully understanding what are our goals for the project, what are their goals for the project, is this really going to be usable, what's going to happen with this, right? I think where some people fall short, and a lot of my previous companies have often fallen short, is that afterwards we kind of go our separate ways and isolate ourselves. The data scientists go work on their project, the software engineers go work on it, whatever it happens to be, and then we lose touch. So what I'm suggesting as part of this new setup to a project is that we also set up like a reoccurring time for all those people to get back into a room and have a conversation. So this could be once a month, this could be every couple weeks, this could be once a quarter, whatever you have time for, but really putting it on the calendar at the beginning of the project and setting that up as a recurring meeting. And we want to do this at the beginning for a couple of reasons. It's a time where we're going to stop developing and move towards how are we going to display this project and how are we going to discuss it, right? And so we have that deadline of when we're going to do that, when we're going to stop this current iteration and move towards how are we going to talk about it. It's also, the point is to be showing them not necessarily a completed project, right? So maybe we have this meeting once a month, maybe we have it every 2 weeks, and in those 2 weeks we haven't made a new product, but we still want to demonstrate the value add that we've had in those 2 weeks or that 1 month or however long the iteration is. So this is not necessarily a time to get together and demonstrate a finished product, but give an update on where the project is, right? And so this also continually reminds our stakeholders and everyone involved what the project is, what the priority is, that it's a project that is still moving forward, and also lets them give feedback, right, if they have new ideas on what we've said. So the side effect of this also is that our stakeholders become more comfortable with us. They become more comfortable with what we do and what the project is. And so when they have questions, when they have feature requests, when there's an issue, they feel more comfortable coming forward and telling us about this. All right, so now we've set up the project. Now we want to move into this like iterative development cycle that I've been talking about. So there's a couple of steps here. Primarily, we want to focus on the use case. So hopefully we already have this overall use case for the entire project that we discussed at that initial meeting. And then each iteration, we want to decide how are we going to move closer and closer to that goal. And this can be a little different when we're focusing on specifically building business value, right? Some teams, especially those who focus on research and development, go into a project to develop a new model and then try and justify that use case afterwards and then end up having to convince people how to use their project. So what we really want to do in this iteration is focus on exactly what we're going to add and get closer to that use case. So there's a couple ways that you get trapped in this, but I want to talk about this idea of diminishing returns. So I think most technical projects face this, right? And it's the idea of you put in a certain amount of effort, and the more effort you put in, the slower and slower you're accruing rewards, right? So maybe at the beginning, it's really easy to see a huge return, but then as you move further and further along, you end up having to put in more and more time to see that same return. And this can happen with time. So say you have a project and you are really trying to make it faster, make it more efficient, decrease the amount of time it takes, right? At the beginning, maybe it doesn't take that much effort. Maybe there's a lot of code cleanup that we can do to make it a lot faster. But at a certain point, it gets harder and harder to shave off time, right? We've shaved off as much as maybe we can or we know how to, and that gets harder and harder. We have to put in more effort to shave off time. This can also happen with metrics, right? So precision and recall, or maybe coverage, whatever you're measuring, at the beginning that could be really hard to, or really easy to increase coverage, right? Maybe there's an edge case we haven't tried. Maybe we can add a bit more data and that hugely increases our coverage of our training data. But then as we get higher and higher, closer to 100%, it gets really difficult to increase our coverage. I think that when we're focusing specifically on how to add business value, we have a whole nother layer of diminishing returns on top of that, right? So not only do we have to decrease time and increase our metrics, but we also have to think about the customer. So maybe it takes us more effort to decrease time, but then that decreased time might not affect our end user. So what we really want to be thinking about is at the end of this, I don't want to come forward and say like, oh, I decreased my model by 0.002 seconds when our model only runs overnight once a month. And I think that happens a lot in research where we get to focus on these incremental time increases or incremental metrics increases when at the end of the day, that might not make a difference to a customer. And maybe it does. Maybe you're losing customers because it takes too much time for your request to finish. And then that is the value add, that you're going to keep customers because they're not upset about how long your loading time is, and not necessarily just the fact that your model takes 0.002 seconds to finish. So at the end of the day, that's really what we want to focus on here, is what is our value add going to be, and how are we going to explain at the end the benefit to the user, and not just we made our model faster or we made it more effective, but really focusing on that end use case and bringing it back to how are we going to explain to other teams the benefit that they are really going to see. So in this particular project, I'm going to focus on this use case of, say we have this initial seed item and we want to be able to recommend similar colors of items. So maybe we have a user who's browsing a page and they looked for this dress, they can't find it, it's not in their size, or we just want to show them other things, and we want to show them these similar recommendations in a specific color. All right, so the next step is that we want to start as simple as possible. So what do we mean by as simple as possible? It doesn't necessarily mean the simplest code possible. This is really talking about like an MVP, and I think when some people hear that, as was said in the talk yesterday, some people think like, oh, let me just get one feature out, one small piece. But what we really want to focus on is what is the simplest way that we can create a full system that's going to demonstrate that value add, right? So rather than like the top trying to hit every feature or every option and making it perfect, what's the way that we can say we started here, we're now here, and look at the increased value in between? So what is the simplest way that we can go from point A to point B and show that value add, right? So in this specific example, our V1 of the color, ShopRunner's like V1 of this color model was actually a deep learning model that could categorize products into these 13 different colors, right? So deep learning model, that doesn't scream simple, but the idea was that it was pretty robust, we could get metrics back on it was pretty reliable that it was going to work, and we had people who had worked on similar things before who could get that up and running, right? And that doesn't necessarily hit all of our features, right? We only have these 13 different colors. Anyone who works in machine learning before know that once we train up a model on these 13 colors, it's not trivial to add a new color, to take one out, to make them more specific, right? We'd have to go back and retrain the whole model. But what we do have is a way to take in a product and give back a specific color. And we can then show that to our users. They can play with it. They can use it. They can see that value add of giving users recommendations based on that certain color or filtering out items for a specific color. So like I said, it doesn't have all of our features, right? These are the two of the buckets. These are a bunch of products that were categorized as yellow, a bunch of products that were categorized as blue. You can see here, I mean, we have an item in the bottom here, this dress. is kind of white with yellow print, and that cannot go in both the white and the yellow bucket, right? This is a single label problem, so it has to go in one or the other. We also have, a bunch of different blues in here. Like, these are completely different shades of blue. We have no way to differentiate between one or the other, so we really have to move forward and iterate next time, but we have a stable, robust system that people can see and people can use. So right now we have something like this, right? We have this seed item, we have a bunch of green recommendations that we can show users, and that is so much better than where we were before, where we had no color information, or we were relying solely on the retail information that was messy or missing. Now we know how much coverage we have, we know how likely it is that our predictions are right, and we can, consistently get these color returns. And then the next time we iterate through, we can go back and say, okay, now we have this primary color name, maybe we also want a specific color. So we can go from that previous slide to this one where we get those specific. And again, we're gonna start as simple as possible. So maybe that's something as simple as taking a center crop of the image so that we get the product, and just grabbing the RGB values that we get, clustering them so that we're getting just the distinct colors that we think are in the image. And that's really simple, right? Like, we didn't do any deep learning, no machine learning as part of that. We're really just grabbing all the RGB values and using very simple clustering algorithm. And maybe that's a little messy, right? So this is an example of literally just doing that, right? So here's the original image on the left. We have a center crop in the middle. And then on the right, we have a color plot where each RGB value, or we have one RGB value for each of those clusters. So potentially an RGB value for each thing that we think is a distinct color, each one present in the proportion that we saw it. So this one here is like a little over 50. The one on the far right is there a little over 50%, and then we have a darker one, a lighter one. So maybe that's a little bit messy, but we now have a color name and a specific RGB value, right? And that's a huge add on what we had before. We can demonstrate that value as we move forward, and then next iteration, go back, clean it up, and make it less messy. So our next step is to make it tangible. So this is a step that I think a lot of people skip. And a lot of software engineering kind of gets for free, right? So even if we haven't completely finished a project in software engineering, going back to my experience as a mobile engineer, maybe you haven't finished a new app or you haven't completely redesigned it, but maybe you've added a page, maybe you've added a button, you can show that. Even if you're doing back-end work, maybe you added a feature that is then present in the UI and you can demonstrate that feature fairly easily. So there are cases where it's more difficult, but a lot of software engineering, I think, kind of gets this for free. So in data science, we have to do a little extra work to build this oftentimes, but I'm going to say that it's worth it because I've seen the reaction that you get. I've been the biologist who didn't understand what the project was or how to ask for features when I didn't understand what was happening. And I've also been the software engineer trying to encourage other people to give me feedback and seeing how much easier that is when you have that tangible app to show people and let them play with. So my advice for this, if you can make an API, I think it's really the best starting point, right? Because it's not always super hard to do. There's a lot of tools out there to help you build an API, and then your users can choose what they input, see the output, they can start to see patterns in what happens, and really play with it with what they would actually be inputting themselves in the finished product. Also, bonus if you can make a visual endpoint in the API. So I have a coworker who always likes to take in the input and return images. So in this example, you would return those color swatches rather than just the RGB value. And that way people can really put in their own inputs and see the output. And it's very visual, it's very engaging, and they can move forward with that. Also, demonstrating differences. So in this project, there are different ways to pick which area of the image you want to analyze, and really demonstrating that and making it visual has really helped people to understand how that works and why they should choose one over the other. So in this example, we have a seed image at the top. We have an example where we used image segmentation and again a color plot of the RGB values that we get from that image segmentation, and then a center crop and a color plot of what we get from that center crop image. So really making that visual, showing them the difference, difference, because when I first went up and tried to explain like, oh, this is why you would want to use image segmentation over a center crop or one way or the other, it's hard to visualize what that end result is really going to be if you don't show people examples. Again, we can demonstrate the steps that we take, right? So even if you just change the way the pipeline works, this is one demonstration of one of my early pipelines of this project. So on the left-hand side, we have the full initial seed images. Then we have the center crops. And I did something called super pixel segmentation, which is where we go through the image and join together as one group RGB values that are a similar shade and next to each other. So we're trying to see what do we think are distinct groups in this image, and can we treat them all as one group called a superpixel. And so this is a marking of where those outlines are and what we thought was all one group. Then we have a plot next to that where we took one RGB value from each of those groupings. And then the one next to it is if we had just clustered it initially. And the joint plot is if we then take that single RGB value from each of the superpixels and cluster those together so that we're getting the distinct values that we got from each group. And then showing those steps and making that really visual can help people understand, what that really means, the steps you took, what is happening at each of those stages, and why you might want to include them. We can also show latency, right? So as I talked about, maybe it is really valuable on certain occasions to make your requests a lot faster, right? Especially if it's going to be used in real time or you're doing it on a lot of data at once, you might want to increase the time. So I think a good way to display this is to make it super visual, right? So this is a latency graph of an early request. And here on the right, we have, if we had just done clustering, none of that super pixel segmentation, we're just getting all of the RGB values out of an image and then clustering them. And it took almost 30 seconds, like 29 seconds. And that's a huge wait time for people to have to sit and wait. And then here in the middle, we have, if we just do that super pixel segmentation, how long it takes for us to pull out those groups in an image. And then the blue on the far left, we see if we do one and then the other. So we're pulling out all the RGBs from each group, and then we have to do clustering on a much smaller set, and that takes much less time. So this is a very visual way to show how much faster it's really going to be, right? It's also nice if you can demonstrate that, like show the request, show how long it takes beforehand, and then show the request afterwards and how much faster it really is, and then people can understand the real-time difference in that request that they're making. We can also show data set creation. So a huge part of data science projects is creating a data set. So as part of this, I had to go through all of these specific color names that we have and map them to the 13 general colors that I showed in the beginning. And this took forever, right? It's a lot of manual data labeling. And then it came time to present, and I'd spent most of the time doing this data set labeling. So that's what I demoed, right? I showed these products on the left. I showed their specific names. I showed what general color we had to map them to. And then I picked out some examples that I thought were really difficult, right? That were really hard for me to label, that I thought was in between. And so not only is this demonstrating how hard it was to build a data set, but it's also demonstrating the benefits of having those specific names, right? Like if we can't categorize these into a more general one, we really need those specific names to do it for us. I also do a lot of demoing of metrics. So one time as part of this project, I had to go through, send a bunch of product images through Phoenix, through the new project, get those mappings to the more general names, and then test them against validation images that we already had that had those general names assigned to them. And then I broke it up into exactly what the discrepancies were, right? So we have a bunch of them that are correct. We have some that have like cropping issues, so maybe we're pulling out the wrong product. And then we have some confusion between certain categories of color. But then we also had some messy data, right? So we also want to show that. So we have something like this where the label on the image or on the product that we were given is orange. Phoenix, or our project, returned pink. And so maybe we can show something like this of our actual specific name of peachy pink or peach is correct. And this is not necessarily a false label or a bad label, but just showing how this data can be messy or confusing. and also an incorrect labeled one, right? So we didn't manually label these validation images. We don't know if they're 100% correct. So really showing that our expected label, or the label that we had on this validation image was green, but our model gave it black, which I would argue is a better label for the primary color in this item. And I think a lot of people don't understand why our metrics or our models are so influenced by messy data. So something like showing this of, we're getting a low % correct in this certain area, but a large portion of that is because the labels we have are incorrect. And showing that, demonstrating that, can really help to explain to other people why it matters so much that our data be clean. All right, so now we've talked a lot about what exactly we want to demo. I'm going to talk about the demo itself. So I think it's really important, especially since there's so much confusion around data science, to start off with a problem statement of exactly why your product is difficult. So this is the exact slide I used in one of my early presentations of this project of explaining why it's really hard to get color from a product. So as an engineer, it might seem super easy, right? We already have RGB values in the actual image. Why can't we just go in, grab them, and get the color for the product? And so what I really wanted to demonstrate here was, if you see this item, if we look at the top where the ruffles are kind of in the light, we get this really light RGB value. Whereas we look in the middle, we get kind of a middle blue RGB value that maybe is representative of this dress. But if we look at the shadow, we get this super dark RGB value that I would argue is not representative of this dress. And the thing is, we can't just take the average of all these, because what if this were a striped dress? What if there are multiple colors in the image? How are we going to figure out which colors we're going to consider real colors and which ones we think are just shadow? This can be a really difficult problem. But also, for deep learning, color is really subjective. So does anyone remember the whole white, gold, blue, black dress? Who thinks this looks white and gold? Raise of hands. Anyone? No? No? Okay. Who thinks it looks blue and black? Who thinks it looks like something completely different? Okay, yep. I had a friend tell me that it looks like gold and blue, so I guess there's all kinds of options, right? And this is kind of an entertaining example, but it also goes to show how difficult it is to build a robust data set. If you're trying to train a deep learning model, or if you're trying to even confirm if what you're doing is correct, it can be really difficult when that's such a subjective opinion. I went through a lot of products where I wasn't sure what the color is, so I asked someone else and they gave me a completely different color than the two that I had been considering. And really demonstrating that and why this is such a hard problem was really important, because I think it seems not necessarily trivial, but an easily solvable problem from the get-go. I also can think it'd be interesting to show not necessarily competitors, but what other people are doing. So this is not to bash on any retailers, but just to show how hard this problem can really be. I went to some retailer websites and took screenshots of things that they had labeled as purple. And so as you can see, some of these are purple. A lot of them, I would argue, are red or blue or even gray. And so it's not a very clean system, even in already production retail sites, right? No one is necessarily doing this problem super well already. You might think maybe purple is just really hard to classify. So I also included some images of red, which I think are okay, but we still see a lot of these examples of things that maybe are a little brownish, maybe are completely brown in the belt, maybe have some red in them, but might not be primarily red. So just showing that this is a difficult problem that not everyone is solving, right? So maybe our V1 is actually better than what a lot of people already have. Maybe one of the iterations we're doing is actually showing a value add over what we're competing against and what already exists in the market. And so this has helped me a lot with getting stakeholders on board with how long it takes to build a data set and why it is so important that we spend so much time on it. I think there's a lot of misunderstanding of, why do you need to do so much research development? Why do we need to do so much testing in data science? Why do we need to try out so many different things? Why does it take so long to build a data set, right? Why can't we, there's a lot of outside sources that can label data for us. So why can't we just contract them out, right? If anyone work with or Figure 8 or even other data labeling problems, right? A lot of times they do a good job, but a lot of times that's also super messy and we have to spend a ton of time cleaning it up to make sure that it's actually usable. And I think it can be kind of confusing to other people why exactly we have to spend so much time on that and why we just can't move forward and use the data that we already have. All right, so the next step is iterate. So I think we've talked a little bit about all of these steps, how to move forward, how we're going to increase the value each time, and then we want to just go through it and do it all again, right? So we have our use case, we have our overall use case, we have the value that we currently have. How are we going to add incrementally more value each time, go through each step, and repeat the whole process over and over again? And that way, with each iteration, we're getting more feedback, more input, and just more communication with the people who are actually using the product. All right, so now we have a stable-ish product, I hope, at least. Who knows what we're ready to move into production, but we're ready to move it into production. So what exactly do we want to do beforehand? First of all, I would say monitoring. So these are just very basic monitoring of this project. At the top, we have an uptime check that's just a binary 1 or 0, whether we're getting a response. At the bottom is just a very basic response time of the API for a request. And I know there's a lot of debate out there about who exactly should be in charge of monitoring, right? So a lot of companies have a system where the data science team builds this model, finishes it, they do some metrics, they're ready to send it into production, and they kind of throw it over the fence to an engineering team and hope that the engineering team cares enough to build in the monitoring and make it production ready. I would argue that this is something data science should do, and that it helps us in a lot of ways to do it and is worth the potentially minimal time to put it into production. So first of all, they don't make it into production otherwise, right? I think we've seen a lot of cases where data science throws it over the fence, and that's just one more team they have to convince to halt their priorities to work on ours, and that doesn't always work, right? An engineering team might not have time to put monitoring in your project, it might not be on their roadmap, it might get put on the roadmap for months ahead of time and then kind of forgotten about, doesn't get updated when it needs to. So us doing our own monitoring really helps move that into production. Also, you're the one who understands the service, right? We're the ones who built it, you're the one who understands it, and so we should be the ones to put in that monitoring because we know what to do if it breaks. It also builds trust, right? So we've talked this whole time about how to convince other teams to possibly set aside their priorities in order to use these projects. So if we spend all that time convincing people and working with them to make sure it's exactly what they need, and then we have no idea when it breaks, and we're relying on them to come to us and say, your product isn't working, so all of our stuff is working, they're not going to want to put that effort in to use our project next time, right? Whereas if we can be the ones who say, we know it's broken, we're working on fixing it, they will rely on us more in the future and be more willing to work with us and use those products in the future. I think we heard in the keynote yesterday, right, data science projects debatably never end. And I think that this can help us a lot, right? That you might have to move on to a new project. You might have to retrain the model. You might have to put something new out, and having these monitors in place can make that a lot more reliable, so you feel okay moving forward, moving on to something else, or completely iterating through the project again, and you'll know if something breaks and you need to go back to it. Also, documenting it. So this is just a basic README of exactly how to use the product if you want to use it in production, but also includes if you need to test it, if you want to change something, if you want to add a feature and you want to test it on your own machine, it's all the instructions that you need in order to do that. And I think this is a really important part of having that documentation in place of how to test it, how to use it, how it all works, but then also where to look if it breaks, right? So we also have a document of these monitors go off, these alerts go off, something's not working, where should you look in each project to fix it, or who should you contact if you're not sure? And that's a hugely important part of this. It goes back to building that trust and making your project maintainable even if you have to move forward to something else. And again, you might forget. I think we've all been in that situation where we go back to a piece of our own code or something we've built years ago, even months ago, and we don't remember how a part of it worked. So having this documentation in there helps other people, but also helps you when you go back to your project. All right, so overall recap of this project, right? We can keep up engagement from our stakeholders and our users. We're continually reminding them. We're also getting feedback from them at each juncture, so they can give us those feature needs. They get to really play with the application and give direct feedback on, okay, I like this part. I would rather have this part. I need to change this section or this structure, and that helps keep them engaged, make sure it's what they really want, but make sure they're also excited about it and still ready to use it. We get to iterate faster, right? So if we put out one of these iterations and they say, oh, actually, this isn't the format I wanted in. I definitely had that experience as a software engineer where I built an app exactly based on how someone said they wanted it, they play with it, they realize they needed something different. But if you're meeting with them every 2 weeks, every month, every quarter, whatever it is, then you can directly go back and change that rather than seeing them 6 months down the line and realizing as a decision you made at the very beginning doesn't work for them, right? So we're much faster iteration. We get to do this in sections. We can change things quickly based on what they say. Also stakeholder understanding. So the people that are working with us, the people that are investing us, maybe your managers, the executives, they're understanding why what you're doing is taking a long time. They're understanding why you need the resources you're asking for because you're constantly demoing how you're using those resources, even if it's not a finished product. Yeah. So this is a little bit of future reading. I talked a little bit about metrics, and one of my coworkers wrote a blog post on it that I think is really cool. This is a future reading about the 13% production. If you want to read a little more about that and other people's opinions on it. And also a huge thank you to all these people and generally the data science team at ShopRunner. They've been very helpful and supportive throughout this whole process, so I really appreciate it. All right, thanks. One minute. All right. Speed question.
For the monitoring section, do you also monitor any metrics related to the delivering of business value? Like, for example,
okay.
if someone buys something after searching the colors.
Yeah, so not on this project specifically yet, but I would advise doing that. I think there's a couple things that you should monitor. Uptime, I mean, the basics that I showed, but also if your inputs drastically change or your outputs drastically change. And then I think something like if people shop for that based on what you do might not necessarily be a data science problem. It depends on how the company is structured, but we don't necessarily have access to that live, like who clicked on what button. So whoever has access to that data, I definitely recommend adding monitoring into that. We do like specific A/B testing to get that information. So we'll hold out a section where we don't show this new method. We'll give a section where we do show this new method and see, do more people click on the recommendations that have the new specific color information versus the old color information. If that is something you can put into monitoring and make that automatic instead of like a manual process, I 100% recommend that. I do know that it is more difficult on certain projects. Yeah. Okay. Oh yeah, I also have Phoenix stickers. So if anyone would like a takeaway from the talk, please come grab a sticker.